congruence, right? What does it mean for two triangles to be congruent? Same what? Same measure of what? Same measure of angles and degrees. Yeah, that would be measure of angles. And same what? Length of sides. Good. Congruent means same shape, same size. When I say same shape, I'm referring to the angles, right? Right triangles have a certain shape that's different from an obtuse triangle. I'm talking about the angles. If I'm talking about size, then I'm talking about the side lengths. If I have a really big triangle, I have really long side lengths. If I have a really small triangle, I have really small side lengths, right? So same shape, same size, that makes congruent triangles. So I need to have all three of the same angle measures and all three of the same side lengths for two triangles to be congruent. Does that make sense? Okay. So we've got a super labeled up image here with two triangles. We've got triangle EXY and triangle EFD. And we're going to identify the congruent sides and the angles. Then we're going to make a congruency statement about these two triangles. Now it's pretty obvious based on how it's marked up which sides are congruent to which. Right? If I take a look at angle E here, which angle is congruent to angle E? Well, what angle is that? Angle E. Angle E is congruent to angle E. That one's obvious because they share that middle angle. What type of angles do we call these two angle E's? Vertical angles. So of course they're congruent because vertical angles are congruent. What angle is congruent to angle X over here?
F.
F? What makes you say F?
Because they have like the same number of lines in it, like the same number of lines.
Measure markers. That's right. X and F both have a double measure marker. So angle X is congruent to angle F. Could I also say that angle F is congruent to angle X?
Yes.
Yeah, because of the reflexive property. I can flip that around if I wanted to. So which angle is congruent to angle Y?
D.
Angle D. And again, could I also say that angle D is congruent to angle Y?
Yeah.
Yeah. They're both congruent, so it could go either way. All right. All three of my angles are congruent with between these two triangles. Does that mean that these two triangles are congruent?
Not yet.
Not yet. What do we call two triangles with all three of the same angles? It starts with S. You guys learned it last year, I think? Similar. If I have two similar triangles, they have the same angle measures, but their side lengths may be slightly different. Now I need to check the side lengths and make sure that those are all the same for these to be congruent. But this one we have to pay a little bit more attention to. This side length here is XE. We'll use that as our first one. XE. Oops, that's XX. XE. What side length in my, you know what, I'm going to call this 1 and 2. So XE is on triangle 1. What side length of triangle 2 is congruent to XE? Yeah, Aldrich? EF. EF right here. Give me a thumbs up, you agree with that. Thumbs down. Colby, why do you say thumbs down? EF is congruent to EY. We'll see how XE has this single.
Oh, yeah. Oh, wait, never mind.
Yeah. So they are congruent, but you're partially wrong. This is the side that is congruent, right? But here's what we have to be careful with. When we're naming congruent sides, the order of points has to match, okay? So XE is congruent to, I can't say EF, I have to say FE. E. This tells me that X and F are congruent and E are congruent. Does that make sense? Kind of?
Yeah.
So I can say XE is congruent to FE. I cannot say XE is congruent to EF. If I wanted to use EF, I'd have to use EX. I know that's a lot of letters. Basically, right, my first letters have to be congruent, the little orange ones. And my second letters have to be congruent, these little teal ones here. Right, they have to match up when I'm writing those names. Everybody cool on that? Okay. Let's look at XY. Here's XY. It's got the little double side length markers, congruency markers, whatever you want to call them. XY. Who can help me name what side is congruent to XY based on this image? Liana? DF? You said DF, right?
Yeah.
Give me a thumbs up you agree with that. DF. Does that work? Slightly off, right? You said what? FD?
Yeah.
That sounds better. FD. Because which angle is congruent to angle X?
F,
Angle F. Which angle is congruent to angle Y?
E.
D. Any questions I can answer so far? Okay. Is this making sense?
Yeah.
Cool. Good to hear. Finally, what about Y? I'll call it EY. Side length EY must be congruent to what? Yeah, Alex, what is it congruent to?
ED.
ED. Give me a thumbs up. You agree with that? ED sounds good. Yeah, Andrew agrees. Raven agrees. I agree. ED. Again, E is my little teal angle. Y and D, those are my lavender angles. Okay. Now I'm going to make a congruency statement about these two triangles. All right? What do you want to call triangle 1? Triangle what? XEY? XEY. Let's do that. Triangle X, E, Y. What else could I have named that triangle?
EXY.
EXY. Yep. EYX. Could have called it XYE, YXE, or YEX. Could have called it any of those. What I start with isn't as important. What I'm saying this is now congruent to is extremely important. My second triangle here, I've got to match up all my congruent corresponding angles, right? So all the colors have to match. Now that I've called triangle 1 XEY, there is only one name I can give triangle 2. Take a moment, think about what that name is, see if you can figure it out. It's color coordinated. Aaron, what'd you say? FED. Give me a thumbs up. That's what you came up with. FED. Perfect. F is my orange angle. E is my teal angle. D is my lavender angle. I cannot say that XEY is congruent to DEF. So that'd be flipped. My corresponding angles have to be in the same spot, whether I'm talking about a side of the triangle or the whole triangle itself. Quick show of thumbs, how's that sounding? Up sounds great, sideways sounds okay, Down sounds bad. Okay. Perfect. So if I'm looking at, you know, oh, never mind. We'll talk about that later. All right, let's move on to these fun little guys down here. Okay, proving that two triangles are congruent. Now, obviously they're congruent if I see all these signs that say, oh, my angles are all congruent to each other, my sides are all congruent to each other. That's easy. But what if I don't have that much information? Well, here's like the bare minimum information we need to show and prove that two triangles are congruent. There's 4 methods. The first one is called what? Side, side, side. Also known as SSS. Okay, everybody say side, side, side. Okay, say SSS. Okay, that's this theorem here. This theorem says that basically if I have 2 triangles, oops, I messed one of these up. Can you add 2 little hashes down there on the bottom? So this theorem says that if I have 3 corresponding sides of a triangle that are all congruent, then the triangles are congruent. Do I even need to know what the angle measures are? No. Why don't I need to know? Because if all 3 sides are congruent, then all 3 angles have to be congruent. Imagine, for example, this side length here was extended by just a tiny little bit. What would that do to this top angle? Make it bigger, right? If this side length extended, right? Well, now this side is getting longer, which makes this angle bigger. So with these 3 side lengths, if I were to say, you know, this is 1 unit, this is 2 units, this is 3 units, there's only 3 angle measures that those 3 side lengths can make. I know that's kind of tricky to wrap your head around, but SSS is the easiest one. If all 3 corresponding sides are congruent, the triangles are congruent. Does that make sense? Okay. The next method we have is angle, angle, side. Everybody say angle, angle, side. What's the abbreviation for that one? AAS. AAS, okay? So this says I've got, you know, this bottom left one. Those are congruent. Boom, boom. I've got this top angle that's congruent. Boom, 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 boom. And I've got this side length that's congruent. Boom, 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 boom. So we can use this when we have 2 corresponding angles. I'm going to abbreviate to corresp. You know that means corresponding. 2 corresponding angles and a side not between them. Are congruent. So I have 2 angles. It doesn't matter which angles they are as long as they're corresponding, right? In this case, bottom left and top. The bottom lefts are congruent. The tops are congruent. And I have this side that's congruent. But the side's not in between those 2 angles. It could be over here. It could be down there. But it's not in between them. All right, today's just going to be an introduction to this. We're going to be proving them and talking about all that later. So don't get your head too far in a twist. Just be able to recognize when we have side, side, side versus angle, angle, side. You guys see the difference between those two?
Yeah.
Okay, cool. Then we have angle, side, angle. Everybody say angle, side, angle.
Angle, side, angle.
What's the abbreviation for that one?
ASA.
ASA. That's when we have two corresponding angles and the side between them are congruent. Right, so I've got this bottom left angle down here. I've got this top angle up top. And I've got the one and only side that's in between those two angles. And finally, we have side, angle, side. Everybody say side, angle, side.
Side, angle, side.
What's my abbreviation for side, angle, side?
SAS.
SAS. SAS. So this shows me I've got two sides that are congruent. My bottom sides here and my little top sides over there. And the angle between those two sides is congruent. It's like the opposite of ASA, obviously. Two corresponding angles. Two corresponding sides and the angle between them are congruent. How's that all sounding? Confusing? A little? Okay. Like I said, today we're not going any deeper than just recognizing which of these four cases we have. Sometimes we're not going to have any of these cases. Right? Wherever you have some room, go ahead and write the non-cases. The non-congruent cases. We already talked about angle, angle, angle. Right? Just because I have all three of the same angles, that doesn't necessarily mean they're congruent. It does mean they're similar, but not necessarily congruent. Yeah, Tyler?
How would it be not?
Was that? How would it not be congruent?
Yeah.
I can have two triangles with the same angle measures that have different length sides because the side lengths would be proportional. That's what similar triangles are, right? Do I have a poster on similar triangles? Yeah, right here. Similar triangles. So the side lengths, it's like a dilation. It's essentially what it is. If I dilate my shape by a factor of 2, I'm making it twice as big. Am I changing what the angle measures are? No, they're always going to add to 180, right? So my side lengths are getting longer, but my angles are staying the same. All right? It's like how how you're born with full-grown eyes?
Yeah.
Have you guys ever heard that? So your eyes the size your eyeballs are right now is the size they were when you were born. That's why babies always look like they have these really big eyes, because they haven't grown into them yet. It's true. So think about like that. Your eyes are the angle measures, and your body is the side lengths. Your body's getting bigger, but your eyes are staying the same size. Isn't that creepy? It's going to give you a nightmare, hopefully. Liana?
Your eyelids also stay the same size? Or do they...
Your eyelids?
Yeah.
No. Those grow. I don't know why your eyes don't grow. Actually, let me make sure that's true. I don't want to be spreading lies. You're going to go home and be like, Mom, my eyes are the same. You're like, what are you talking about?
Oh.
What? Where did I hear that your eyeballs don't grow? Did anyone else hear that? No one else has heard that your eyeballs are the same size as they've always been.
You're spreading out. Is this real?
Why did I?
Whoever told you that doesn't like this.
Only your first 2 eyes.
But your eyeballs go like
Where have I heard that? At least I checked, okay? I retract my statement about the eyes.
The bottom part is fully grown from birth. Click that one. Even if Lula's against you.
Huh?
See, now this says eyeballs are fully grown. But I don't know. That's AI, so it's probably wrong. Eyeballs are the 4th organ in the human body that does not grow after birth. At birth, they are the same size, and when they die, they are also the same size. Even after birth, they reach their full size. The size of the head and brain.
They got the information on Wikipedia.
I think whoever wrote this is
Wikipedia said information.
I think so, Christian. I think your head does grow. See, okay, I don't even know what's happening right now. American Academy of Ophthalmology. That has to be true. Okay, well, I'm wrong.
This talking discovery, I think this is not
Whatever. I don't know where I heard that. Don't go around repeating it. Apparently it's not true. Doesn't matter. Okay? Sorry. Yeah, you're going to tell everyone that I said that? Good. Okay, anyway, sorry. That was a ridiculous side quest that we went on there. So, angle. Don't worry about the eyeballs. Not necessarily congruent if all my angles are congruent, right? What's another case? What's the only other case that we're missing here? Angle side. Angle side. What does that look like? Angle side. Nobody sounded out. Okay, if I have an angle, a side, and a side. Yeah. Angle side. I think you guys can pronounce that. So, this is a good way, again, this is what I learned in 8th grade. This is a way to remember that these two are not congruent cases. Because when when you're on the test, all the S's and the A's are going to get super confusing. If you just remember that this is not true, and just all the A's, I don't know what you would call that, but just like a scream. Yeah, there you go. That sounds about right. Aaron, sure. Yeah. Liana? Why isn't angle side true? That's a great question. We'll talk about that when we get into proofs. Huh? No, we're going to prove all these triangle stuff too. Yeah, we'll talk about it later. But these ones are not necessarily congruent. So what we would say if I see something like this is that I have not enough information. Just like me when it comes to eyeball growth. Don't have enough information. All right?